All right, welcome to The Explainer. Today, we're going to dig into a pretty forgotten story from Bitcoin's absolute earliest days. We're going to uncover how the first ever payments actually worked, and I promise it's probably not what you're expecting.
So when you think about a Bitcoin transaction, right, you're probably picturing something simple, sending money from A to B to a public key, kind of like a digital address. But what if I told you that from the very beginning, it was never that simple? The reality is actually way more interesting. Turns out, every single payment was being sent to a tiny computer program called a script.
Okay, so what on earth are these scripts? To really get it, we kind of have to shift our whole way of thinking. I want you to imagine every Bitcoin payment not as just sending money, but as creating a puzzle that needs to be solved.
Okay, so here's the core idea. When you receive Bitcoin, you're not just getting coins in a wallet. You're actually getting a lock. It's a little challenge, right? Defined by something called an output script. And to spend that Bitcoin, you have to provide the key, the solution, in what's called an input script. It's this brilliant, simple lock and key system.
Okay, but why? Why all the extra work? Why not just send payments straight to a public key? Well, as it turns out, there was this huge practical problem that early Bitcoin had to figure out if it was ever going to be, even remotely user-friendly.
I mean, just look at this thing. This right here, that is a single Bitcoin public key. Now, just for a second, imagine trying to read that out loud over the phone to someone so they can pay you. It's a total nightmare, right? Completely impractical for any kind of real-world use.
So yeah, this was a massive problem. If Bitcoin was ever going to be used by, actual people, there had to be a better way, a more human-friendly way to get paid.
So the very first version of Bitcoin, version 0.1, it had this clever, if a little bit wild solution that's been long gone for years. You could actually pay an IP address directly.
So here's how it actually worked. Alice would literally just type Bob's IP address into her wallet. Their computers would connect to each other directly, and Bob's wallet would automatically shoot over a brand new public key to Alice's wallet. And then her software would build the entire payment script, all of it, behind the scenes. Pretty slick, right?
Now, as you could probably guess, paying IP addresses directly had some pretty major security and privacy problems, so that feature was eventually stripped out. But the way it worked, that script it created under the hood, that's the real story here. That was the blueprint for pretty much everything that came after.
All right, so let's pop the hood and take a look at that very first payment script. It's called Pay to Public Key, or P2PK for short, and this is the simple little program that was powering all those early IP payments.
So this is exactly how that puzzle was built. The output script, that's the lock, right? It had two parts. First, the public key that was just sent over the IP connection, and second, a command called op_checksig. And the input script, the key, well, that was just the digital signature from the person trying to spend the money.
Okay, so how does the network actually check if the key fits the lock? It's pretty cool, actually. It combines those two scripts and processes them using a concept called the stack. The easiest way to think about it is like a stack of plates. You can only add a plate to the top or take one off the top. First up, the network takes the key, that's the signature, and places it on the stack.
Next, it takes the public key, part of the lock, and places it right on top of the signature.
And then the final step, the op_checksig command runs. You can think of this as the final turn of the key in the lock. It pops both items off the stack and checks one simple thing. Does this signature actually match this public key for this specific transaction?
And if everything checks out, if the signature is valid, the command leaves a single item behind on the stack, the number 1, which basically just means true or success. And that's it. A 1 means the puzzle is solved, the script passes, and the Bitcoin can be spent. It's just a beautifully simple and elegant way to prove ownership without a central party.
Okay, so IP payments and these P2PK scripts, they're basically ancient history now. They're relics. But their legacy, what they left behind, that is by far the most important part of this whole story, because it fundamentally changed our idea of what money could even be.
See, the real breakthrough wasn't the kind of clunky method of paying IP addresses. That was just a temporary solution. The real invention was the scripting system itself. It proved that from its very first transaction, Bitcoin wasn't just digital cash. It was programmable money. And that changed everything.
Think about it. This one idea, that payments are actually little programs, that's what paved the way for everything that followed. Multi-sig wallets, the Lightning Network, it all traces back to this. Which leaves us with a really fascinating question to think about. If this was the kind of power that was hidden inside Bitcoin on day one, what else is still waiting to be unlocked?